Welcome back to Study Sprint. Have you ever wondered how we managed to organize the entire universe of elements into one tidy little table? Well, the periodic table wasn't always the perfectly ordered chart you see today. It's the result of centuries of experiments and breakthroughs. So in my today's video, we're diving deep into the story behind the development of the periodic table. During the 19th century, chemists were finding new elements almost every year, so they were also trying hard to find patterns in the behavior of the elements. They wanted to organize the elements in the order to understand more about chemistry. In the early 1800s, John Dalton proposed that all matter is made up of tiny, indivisible particles called atoms, and that each element is made of its own unique type of atom. While Dalton didn't directly contribute to the periodic table, his atomic theory provided the framework that made it possible to categorize elements by their atomic weights and later atomic numbers. In 1808, he published a table of elements in his book, A New System of Chemical Philosophy. Johann Dobereiner, who was a German chemist, noticed something intriguing. He discovered that certain elements could be grouped into sets of three, which he called triads, where the middle element had properties that were an average of the other two. For example, lithium, sodium, and potassium formed one triad. The atomic weight of sodium was roughly the average of lithium and potassium, and their chemical behaviors were strikingly similar. In 1864, British chemist John Newlands tried his hand at organizing the elements and proposed what he called the law of octaves. He noticed that when elements were arranged by increasing atomic weight, every eighth element had similar chemical properties. His idea worked well for the lighter elements like sodium and lithium, where the pattern was clear. But there was one major problem. The pattern started to fall apart for heavier elements. For example, after calcium, the properties for every eighth element didn't match up. He constructed his periodic table, but to keep the octave pattern, he would sometimes have to put two elements in the same box. Newlands also didn't leave any gaps for undiscovered elements, which meant his system was too rigid to accommodate future findings. So Newlands' idea wasn't taken seriously at the time. People thought it was too simplistic. In 1869, the Russian scientist Dmitri Mendeleev arranged the known elements by atomic weight, but he also left gaps in his table. Why? Because Mendeleev believed that elements yet to be discovered would fit perfectly into those spaces. This was revolutionary. Mendeleev's table not only organized the elements, but also predicted the existence and properties of elements that hadn't been found yet. And guess what? He was right. Elements like gallium and germanium were discovered, and they matched his predictions almost perfectly. Mendeleev's periodic table was so powerful because it not only described the elements we knew, but it also predicted those we hadn't found yet. But the story didn't end with Mendeleev. In the early 20th century, British physicist Henry Moseley made a critical update. He discovered that the elements should be arranged by atomic number, not atomic weight. This was a game changer. Moseley's work explained why some elements didn't quite fit in Mendeleev's original table. It was the missing piece that transformed the periodic table into the version we use today. The modern periodic table, as we know it today, is organized by atomic number, which is the number of protons in an element's nucleus as proposed by Henry Moseley. It's arranged in rows called periods and columns known as groups. Elements in the same group share similar chemical properties. The staircase drawn on the right of the periodic table in bold black is the dividing line between metals and nonmetals. The elements to the left of the line are metals. The elements present to the right of the line are nonmetals. The periodic table helps us understand how elements interact, predict chemical behavior, and even discover new elements. So next time you look at the periodic table, remember it's more than just a chart of elements. It's a living, breathing roadmap to the building blocks of the universe, and it's still growing. Thanks for watching. Don't forget to like, subscribe, and hit the bell for more deep dives into the wonders of science. See you next time.